Hey everyone, I'm Luca. I do research at L2BEAT. I'm not a cryptographer, I'm not a Ziki engineer. My job is to provide transparency to the space, and this is what this presentation is about. And precisely on why ZK is not all we need. So this is, Ethproofs Summit. I opened a few links that are recommended in the website to explain what ZK is, and I found these two resources. One of them says, ZKVM is driving the future of verifiable computation, right? Another one says, ZKVMs compress any number of Ethereum transactions in a single low-cost and succinct validity proof. This allows for delegating the running of the EVM to powerful nodes with no trust assumptions. And again, L2BEAT job is to assess where the trust is, and saying no trust assumption like are big words for us, right? So what does it mean? Like, what does verifiable computation with no trust assumptions mean in practice? At the limit, no trust assumptions means that you can verify a computation just by trusting yourself, right? And trusting yourself, just by trusting yourself, like if you really think deeply about it, it's actually not possible, right? Because there are many tech components in the stack, and realistically, you cannot go check all of them, right? There is some software components, some hardware components, there is some theoretical components. The math is difficult. You cannot check everything, right? You might not have the knowledge, you might not have the time. This is just impossible to have something that, at the limit, doesn't have trust assumptions. So if you want to check something, and you know that it's not possible to do everything yourself, what you do is that you delegate the verification to someone else. But this means adding trust, right? And this is a problem. This is a problem, so how do we minimize this problem? So there was this conversation, very nice conversation on Twitter on this problem. I think these comments from Mika were responding to POTUS. And POTUS was saying something like, my mother or my grandmother shouldn't be able to read smart contracts before using an application. Like, we shouldn't require this from users, right? Which is, of course, realistic. I agree with this. But again, in an ideal world, your mom would reach out to her trust network and ask, is X safe to use? Someone then audits or asks their trust network. The goal is to maximize the set of people who can audit the code, so the number of hops between mom and the auditor is as short as possible. So again, you cannot check everything yourself. You should ask your peers if something can be trusted or not. You can imagine this trust network as a graph, maybe a weighted graph. And what you want to do is to maximize your level of confidence, right? And these weights probably degrade the further you go in the graph from you, right? So you want to delegate the trust to as many people as possible with the most confidence as possible. So going back to ZK, I want to use a ZK rollup, right? What should I do? First, you need to trust the L1 RPC. And trusting the L1 RPC means either you trust Alchemy, you trust QuickNode, or you run your own full node. If you run your own full node, of course, you need to trust this software that you're running, right? So you're running Geth, you should check Geth or delegate the verification to someone else. Maybe, it's its own rabbit hole, right? You could have multiple clients, whatever. Then you need to assess the L2 code that is on L1. You need to check the smart contracts, whether there are forced transactions, whether you can run a prover, whether the verifier is not gated, right? If the proof system is correct. And again, this is another rabbit hole. And then there is the L2 RPC, similar considerations for the L1 RPC. Maybe a bit more complicated. So What we do at L2BEAT is the second part. We look at the smart contracts. We try to assess the smart contracts, and we have this nice risk pizza that also Ethproofs started to use, right? The thing is, if you're not checking the contract yourself, you might use L2BEAT as your delegated trust. But the thing is, this is not comfortable for us, and it shouldn't be comfortable for you. Like, you shouldn't just trust L2BEAT, right? So how do we fix this problem? We fix this problem by explaining how our projects work, right? We draw diagrams, we have very deep descriptions, we provide links to all the smart contracts so that if you don't trust the L2BEAT assessment, you can do it yourself. You can check the contracts, you can check what we write, so that it's also easy for you to falsify what we say. We released this other tool where you can see all the connections between contracts, the graph, all the values, raw values. So for us, it's really important that, yes, to provide an assessment, but also for you to have the tools not to trust us, right? Another example of this is on Ethproofs, which is the audits, for example. In SP1, they say the project is fully audited, but like, personally, to be honest, I don't trust this value, because I spent some time ago, a week or like a couple of weeks, looking at audits. There was Arbitrum complaining that Optimism doesn't audit their proof system, and Optimism says Arbitrum doesn't audit their proof system as well. And so I spent 1 week looking at audits, and the conclusion is that it's very complicated. Audits are very nuanced. You could audit one part and then another part, and then while you audit the other part, you modify the first one. Then you might have fixes, and then you don't audit the fixes, right? So what I want to say is, if there is a website that says that something is fully audited, please provide me with the links of the audits so that I can also self-assess myself if this is true or not. Like, you shouldn't trust Ethproofs, right? Ethproofs should help you to also self-assess. So L2BEAT checks smart contracts, right? The problem with just checking smart contracts is that it works fine for most things, but when you hit a ZK verifier, what you see is this, right? There are random numbers that represent the verification key or similar, and like, we get stuck. Like, we need to go beyond the smart contracts to understand what a ZK rollup is verifying. Like, from here, of course, you cannot distinguish between a ZK VM being proven or Sudoku puzzles, right? And this is very important because actually there have been problems inside these projects, right? And to know that there are problems, you need to look at the source code, and you need to be sure that the source code you're looking at is actually what is being verified on chain. So this example is Linea. Linea for a very long time had a under constrained proof system. They were not proving all the execution. They just fixed it like these past few days, I think. They managed to get to full soundness. But like, these are security concerns, right? And the only way to check this, like kudos to Linea for being honest, but like, we don't know about the other projects, right? If they are under constraint, the only way to do this is to check the verifier. Another example is the Semaphore case. Last year, we tried to regenerate the verifier for Semaphore, which is one of the simplest projects for specifically the WorldCoin verifiers. And after weeks, turns out that it's impossible to get the on-chain verifier, to reproduce the on-chain verifier that they use, because the Circum version that they used at the time is non-deterministic. So it's impossible to get the same R1CS file because the order of constraints is non-deterministic or whatever. So it's impossible to verify what WorldCoin is doing on-chain. Like, it's just not possible, right? ZK is supposed to be transparent, trustless. With WorldCoin, at least with this old verifier, I think they changed it, it's impossible to know what they're doing. So there are many problems today with ZK. Finding good docs on how to reproduce this verifier is extremely difficult. This is for Semaphore, again, for WorldCoin. like you need the exact, for example, commit hashes to know like the commit of the tools you need to use to reproduce the verifier. And most of the time, they're not shown in their guides or in their documentation, right? I spent weeks trying to get to these commit hashes by bisecting the repository code myself, because I couldn't get this verifier, and even the developers themselves didn't remember which commits they used, which version, which release they used to generate the on-chain verifiers. Every project uses custom tooling, right? This is from zkSync. The other one is Scroll. They have their own tools. And now, like even if you can reproduce the verifier, now you need to trust the tool that you use, because it could be that this tool just does random computation and gives you the verification key at the end without any meaningful connection to the source code. And this is a problem because, again, this adds complexity to this verification, right? And sometimes generating verification keys might be hardware intensive. It might require hundreds of gigabytes, so it's not something that it is as easy as checking a Solidity source code, where you just need to compile with Sol-C or whatever. So, and it takes 5-6 hours. This is from an old Polygon documentation. I think right now with the new version, this is even higher, the hardware requirements. So we want to provide more transparency to the space. We kind of want to fix this problem. We want to expose those projects that whose verifier cannot be reproduced. Because again, this is equivalent to an unverified smart contract. You have no idea what it is being proven. So we will have a list of projects. We're working on this page. This is a proof of concept. Don't trust the values. This is done by our designer. But the idea is that we want to list these on-chain verifiers. We want to show how much value they secured, which projects use those verifiers. Verifiers count, which is, some projects could have one that uses gross 16 as the final wrap, another one uses Splunk. But then we also want to have this column that shows attesters, right? So it's not possible, we think it's not feasible to build a backend that does the verification of that reproduces the on-chain verifier from the source code, because this requires arbitrary computation, right? All the tooling is custom, so you cannot have a backend like Etherscan that just compiles Solidity contracts, right? So it's not possible to have a generalized backend. You need to go one by one for all the projects to try to match the source code. This is very complicated. We probably not do this for every project. So we also want to outsource this verification. And also, we don't want you to trust L2BEAT alone. So, for example, you could see that we've gone through this process of regenerating the verification key, the on-chain verifier. You will see an attestation by the L2BEAT that says, yes, this is the source code. But we want to invite other projects to also submit their attestation, that they've gone through the process and they attest that this is indeed the source code. So you will see, Nethermind could do this, OpenZeppelin could do this. We're also thinking maybe to do doing on-chain attestations if you don't want to even trust our curated list of attesters, of trusted attesters. But yeah, we will expose those projects whose verifier are not reproducible, and of course also trusted setups. A lot of projects have very questionable trusted setups, especially those that use gross 16 as their final wrap. One example of them is SP1. Some projects like this, Cosmos, Bridge, IBC, and I don't even remember, Bridge uses SP1 with the gross 16 final wrap. But in SP1, the gross 16 trusted setup is 5 people, all internal to Succinct. So 7, whatever, right? So you shouldn't trust this verifier. And so we will expose also these projects that will do this. And that's all from our side. Thank you.
Beat that brand new ZKVM.
Another one, man. They multiplying like spam commits.
Who's gonna stress it till it taps out? Ghost Roger ZKVM straight into the bay. Through Peterson hash, now your stack can't stay. Trust me, bro. Nah.
Internally verify that they actually have like full coverage of the circuits, or you're gonna like some automated backend there. Because I think it's another area where at least I've personally seen.
Like specifically for audits.
Yeah.
Yeah, so we want to show audits, like we wanted to show audits, also for L2s in general, not just ZK, right? We have a lot of L2s. We want to show that your proof system is audited, or like your bridge is audited. The problem is, again, audits are very, very nuanced. Like it's super complicated. For example, to check whether the audit refers to a version that is actually used on production, because it could be that, yes, you have an audit of a certain up to a certain commit, and then the project just adds commits and then uses that on chain, right? Is it audited or not? Like, it's complicated, right? So we were also thinking about maybe building a framework on how to assess audits, how to audit audits, right? Which is absurd in a way, but like what Ethproofs is doing, I think it's not the right thing. Like, just saying that something is fully audited, I think it's a very big claim, right? So like we want to do this, it's very complicated. As I said, I spent weeks trying to look into Arbitrum and Optimism audits. It's a mess, it's really a mess. And most of the time, even the audits themselves don't say what is the full scope of the audit, because it could be that they missed something, or also it could be that an audit says that there are some problems, right? But these problems are just acknowledged. So saying that something is audited could give a false sense of security if there are issues that are just acknowledged and not resolved, right? So we want to, we'll try, we'll see.